Hi, my name is Ken Bingham with ACM Facility Safety, and I want to use the ACM quad model just to demonstrate a little bit about what we typically can do for a typical client. First of all, the quad model is designed from Q1 through Q4. And basically, it's conceptual stage here, risk assessment, then it's design stage, then it's build and program, install, and then it's operate, maintain. So from that perspective, how do we help our clients? What situations do our clients find themselves into? Well, a typical situation would be, let's say, a brownfield project or a brownfield system where it's an old plant. They've had a lot of spurious trips lately. They create unsafe situations. So how do we help that particular client? That particular client, he looks at his plant and says, look, this is an old plant. I'm probably not compliant to anything. I'd like to replace in kind my systems, but they know that you can't replace in kind anymore. They have to determine, what is my risk exposure. So, leading that client through through these steps would help him be compliant with the most recent standards. And some of the things we would do for a client in the same quadrant one we'd be basically go in there and actually do a gap analysis. We determine what sections of which quadrants they don't have records for, or procedures for, or testing for, or training, or understanding. So underneath all this is the whole understanding of what is this all about. So a bit of an educational process. We would actually get the client through the educational process. Once we get that client to an educated point, to a certain level, then we can actually start going through the first few steps for the client. So we'd help the client perform a HAZOP. We'd help the client go through the first step of doing SIL determination, determining which is the step which determines, do I have any unmitigated risk? And once we do that, then we can actually help the client start specifying what that functional requirements are for those added safeguards that he may be short. Or the other side of it, the flip side is, maybe that client has way too many safeguards, way too many things he's doing to actually mitigate a certain risk. Now there's an opportunity for cost savings, and we can help identify these cost savings along the way with the client. So we're trying to teach the client, educate the client what the process is, and give him enough knowledge so that when he goes through the process, he knows what he's doing. And the output of the process, he can determine for himself whether there's benefits there, whether it's going to cost him money, or whether he can save money. But we'd like to educate the client and give him the heads up so he's looking for these things. He's looking to save money. He's looking to see where he's actually got extensive risk exposure. So that first quadrant is sort of an all-important quadrant, and you get a lot of talented, different types of specialty to do that first quadrant. From HAZOPs, reading P&IDs, understanding how the SIL standards work, that sort of thing. So when you get into the second quadrant, it's more detailed design. So this is where you need instrumentation people. In this first quadrant, really, we're using instrumentation people. We also had process people, operations people, maintenance people, design people. Everybody was involved here. Here is more or less a safety, or not a safety, but an instrumentation engineer. One that's probably certified to actually work on SIL-related systems. Somebody that has a functional safety engineering certification would be qualified to work in this area. Now, once they get in this area, of course, they're going to be doing the SIL modeling and some detailed work and actually describing what these safeguards look like. How much equipment do I have here, and what does it cost? And then he goes into the second quadrant. Now, what we do for the client in this second quadrant here is basically we help them do the SRS specifications, so we specify what they need to do. And then from there on, what we normally would do is hand those specifications over to an EPC or a vendor or to the client so they could actually have some more detailed engineering take place. Because that's sort of our crossover point. That's our handover point. We're sort of shy about going it further. We've done that in the past, but what we find where our most value is basically leading the client through the process, giving him the education and tools to actually get to the functional safety specification stage. Once he gets to that stage, then we give it to somebody that is used to grinding, turning the big wheel, and actually grinding this out, because there is a lot of grinding here, drawings produced, that sort of thing. So that's where we usually hand it over to the client. And the next part where we get involved is usually if the client needs things like procedures for fat testing and what a SIS procurement looks like. We can give them templates, but I think for the most part, most EPCs, engineering procurement companies, and most vendors can do that on their own. I think the biggest step then we have to play is this verification step, where we basically verify that the clients or the third parties that have used to complete quadrant 2 and perform quadrant 3 are basically complete. So we use a set of checklists, and we would actually go through and examine the procedures they used and make sure that actually all the outputs out of this quadrant were met. So we need some documentation to review. So before that third party gets involved, we actually, on behalf of the client, tell them, look, this, at the end of the day, when you're finished, these are the things we're going to check on you. So it's a bit of a QA process we use, and that's called a functional safety assessment. And it's also called what we refer to, it allows a safe plant startup. So the reason you do the functional safety assessment here is to have a safe plant startup. So once we get into that, then there's the operations and maintenance side. So the operation and maintenance procedures, basically were all designed back here. They were all designed back here. That's what separates this kind of critical safety system engineering project from a normal control system engineering project, is the fact that, unfortunately, or for the benefit of everyone, you have to figure out what your operations and maintenance procedures are back here in quadrant 2, in the design quadrant. Normally, in a normal control systems project, they'd be done here, perhaps after you start it up, but in this case, you have to do them here. Because when you get them here, you have to do them here so that when you do start up, you've got them all in place. You don't have to re-engineer anything. So that's where we can help the client a lot in quadrant 2. I'm sort of going backwards and forwards here a little bit, but as I'm explaining the quadrant here, I'm just thinking of things that actually remind me that, oh yeah, this is where we help the client as well. So the operation and maintenance thing is not an easy thing, like the procedures and the checklist is not an easy thing if you haven't done it before. So when he's in operations and maintenance mode, we can go in at any time and perform a audit or gap analysis after they start up, and just to make sure that things are going well, and making sure that the equipment they're supposed to be testing is tested on a certain frequency, and make sure that if they do any changes, those changes are documented, and that the functional safety is actually checked to make sure the functional safety is intact. And of course, everything that we check here is actually compared against the functional safety spec, that SRS spec that was actually designed here. So we designed the spec, someone else goes away and actually executes it, implements it, then we come back at the end of the day and actually check against the spec to make sure it was actually implemented as per the design. So it's a real QA step. Now the way these standards that are behind this are put together, they're actually based on military standards. And the military standards basically, say what you're going to do, document what you're going to do, prove to someone else you've actually done it, and then test that you've actually done it. So that's what we help the client do. Okay, and just to conclude on the functional safety on this quad model, ACM quad model, is that what I've talked about here is actually leading the client through the steps on the functional safety quad model. What we usually lead the client with is a training system with procedures and with the tools so he can actually do this himself. So we basically want that client to be self-sufficient. That's what our goal is, to be self-sufficient. And if we can help that client be self-sufficient, we've done our jobs. They may call us once in a while, but not very often. And it's their risk exposure they're trying to mitigate, they're trying to control. So it's their lives they're trying to protect, not ours. They're out there in their plant, we're back in our office. So it's more critical for them to actually do this than ourselves. But we treat this as a bit of a noble business. We treat the world as the world's not a safe enough place yet. It's not safe enough. And one of our step path forward into the business world is to help the client be self-sufficient, and we do that through education and tools.